So the first question is that for the circuit which is shown below, we have to find the Thevenin impedance at terminals A, B. The options are given. So first of all, we write what all is given to us. The angular frequency is 1 radian per second. The inductance is 1 Henry, resistance is 1 ohm, and the capacitance is 1 farad. And what we have to find is Thevenin impedance across the terminals AB. So the procedure is, the first we have to ignore the voltage source and keep the resistor, inductor and capacitor in the circuit. Moreover, we also know the formulas, and from what we are given, that 1 is equal to j omega L. We know that the angular frequency and the inductor are equal to 1 in magnitude, hence it equals to j. Also 1 is equal to 1 upon j omega c. Since angular frequency and capacitor are 1 in magnitude, j comes in numerator and hence the minus sign, which finally equals to minus j. The second step is that we have to take out the Thevenin impedance. From the circuit, we know that the resistor is parallel to the capacitor. Hence, we find the impedance Z. 1 upon Z equals to 1 plus 1 upon minus J. Therefore, Z equals to J upon J minus 1. Now, Z combined, that is resistor and the capacitor, they are in series with the inductor. And so, the Thevenin impedance is equal to Z, that is J upon J minus 1 plus J, which is caused to the inductor. Solving it further, putting J square is equal to minus 1 and also rationalizing the denominator, we finally arrive onto 1 plus J by 2, which equals to 0.5 plus 0.5 J ohms, which is the A option. Now, the second question is that we have to find the Thevenin voltage at terminals AB in the given circuit. The options are given to us. So again we write what is given to us. Angular frequency is 1 radian per second, inductance is 1 Henry, resistance is 1 ohm and capacitance is 1 farad. And we have to find out Thevenin voltage across the terminals AB. Procedure is that we know that according to the voltage division rule, V1 is equal to the resistance on the very same side, that is R1, upon the total resistance, that is R1 plus R2, into the total voltage. That's how we find the Thevenin voltage. After solving it further, putting J square is equal to minus 1 and also rationalizing the denominator in between, we get the answer as 2.5 minus 2.5 J, which can be expressed in the terms of x plus J y. X is equal to 2.5 here and y is equal to minus 2.5. For converting this rectangular form to the polar form, R is equal to under root of x square plus y square, which is a magnitude. After putting the values of x and y in the formula, we get value of R as 3.535 volts. Also, theta is equal to tan inverse y by x, which comes out to be minus 45 degrees. Hence, VTH is equal to R theta, which equals to 3.535 angle minus 45 degrees volts, which is option A. Next question is that we have to find the Norton equivalent impedance across the terminals A and B, and the options are given to us. What we are given is the voltage which equals to 6 volts, capacitance equal to minus J2 ohms, the inductance equals to J4 ohms, and what we have to find is a Norton equivalent impedance. The procedure is that first again we have to ignore the voltage source. For finding the total impedance, which is also called the Norton impedance, we see from the diagram that capacitor is parallel to the inductor. Hence minus J2 ohms is parallel to J4 ohms. 1 upon the Norton impedance is equal to 1 upon J4 plus 1 upon minus J2, which equals to J2 minus J4 upon minus 8. Hence, the Norton impedance equals to minus 8 into J2 plus J4 upon J2 minus J4 into J2 plus J4. Here, rationalization of the denominator has been done. After solving it further, we arrive at the result minus 3.99 J, which approximately equals to minus J4, which is option A. The last question is that we have to find the Norton current across the terminals A and B now. And the options of course are given to us. What we're given is capacitance is minus J2 ohms, inductance is J4 ohms, and the voltage is 6 volts, and we have to find the Norton current across terminals AB. We know a simple formula, B is equal to IR. Putting the value of V as 6 volts, R as minus 2J plus 4J, we get that I is equal to 6 upon 2J, which equals to minus 3J. Hence 3 angle minus 90 degrees, which is option D. Thank you.